Alright, what we're looking at today are higher order derivatives. And what we can do is just take a derivative like normal. When we do this derivative, bring everything down in front. 20x cubed, this will become 6x squared, 14x minus 15, and the constant goes away. But who's to say I couldn't just, take a second derivative? This would be called y double prime here. When I do that, it would become 60x squared plus 12x plus 14. I can go on and take even more derivatives, a third derivative, a fourth derivative. This is how we notate it because it becomes bad writing all these primes. Well, if I keep doing these derivatives, I get 12 or 120x plus 12. If I do that derivative, I'm just with 120. Well, if I do that derivative, what am I left with? It's going to be just, well, nothing, a constant. So that means anything I do after this, maybe I want to know what the eighth derivative of that is. Well, it's still 0 because I'm taking derivative of a constant. What if I know y to the 14th derivative? That's still just a constant of 0. So I can do as many derivatives as I want. Just in these polynomials, eventually they're going to become a derivative here of 0. Here's another example. Let's say y is equal to sine of x. Well, the derivative of that is cosine of x. I can do that derivative. Derivative of cosine is negative sine of x. The derivative of negative sine is just negative. Derivative of sine is cosine. And then the derivative of this, derivative of cosine is negative sine, so negative times negative gives you a positive sine. Well, hey, look, that's right back to where you began. So guess what? If I did another derivative, y to the fifth, that's going to be the exact same as y prime. It's going to just keep on repeating over and over again. So this is the same as y to the fifth prime. This is the same as y to the sixth prime. So I could even figure out, what if I want to know what y to the 14th prime would be? I could go through, well, this would be the 4th, the 8th, the 12th prime, and then I can go 13, 14. So this would be the same as y double prime, which is negative sine of x. So I can go through and figure them out like that. Let's even do y to the 41st prime. Well, if I count by 4s, I would get 4, 8, 12, all the way up to 40. I need one more. So here's my next one, y prime, which is 20, which is cosine of x. Now, the last thing we can do is problems like these. These are going to be called kind of like differential equations. We'll kind of do this down the road. But I want to show that y plus y double prime is equal to 0. Well, all I need to do is I need to say what y is, what y prime is, and then what y double prime is. So we have here y is exactly as it's written. Y prime, I can just go and take each derivative. And then y double prime, take the derivative of each of those. Well, to show that y plus y prime, let's just write what y plus y prime is. It's cosine of x minus sine of x, that was y, and then adding y double prime, which is negative cosine plus sine. Well, look, the cosines cancel, the sines cancel, so it does in fact equal 0. So there's just a little kind of a proof that you can kind of do in terms of using these differential equations.